Hello everyone, I am Kiran Kumar from Nature of Physics. Today topic is Brewster's law from the Polarization. Chapter name is Wave Optics. Step by step clearly I am going to explain, including diagram, derivation, proof and two numericals. Please do like and subscribe our channel Nature of Physics. See student, light is traveling from the rarer medium to denser medium. Rarer medium is taken as air and denser medium is taken as glass. This is the incident ray. Incident ray is the unpolarized light. UPL represent the unpolarized light. So that incident ray has arrows and also dots. See, their arrows are in the plane and dots are perpendicular to the plane, and dots and arrows are mutually perpendicular to each other like this. So black represent the dot and this blue represent the arrows. So that dots and arrows the light ray has, that light ray is taken as unpolarized light. Natural light is a unpolarized light. So that when light is traveling, that is unpolarized light is traveling from the rarer medium to denser medium, angle of incident is considering that is taken as angle of polarization. So that theta p I am writing angle of polarization. And when light is incident on this medium, that is surface separation of the medium, so a part of light get reflected, that is taken as angle of reflection. This is the reflected ray and this is the incident ray, and remaining part of light is travel from the rarer medium to denser medium. So that light is traveling from the rarer medium to denser medium. This is also taken refracted ray, and R2 is the angle of refraction. One thing notice there, here incident ray is unpolarized light, it has the both dots and arrows, but reflected ray maximum number of dots and minimum number of arrows, and refracted ray maximum number of arrows and minimum number of dots. Whenever the angle of incident is adjusting at particular angle, that is angle of polarization, there all the dots get reflected and all the arrows get refracted. So that here total dots are reflected and total arrows are refracted. That's why this is the plain polarized light, because of it has only dots, that is reflected ray, and refracted ray has only arrows, there is no dots. That's why this is also taken plain polarized light. So notice that incident ray has both dots and arrows, and reflected ray has only dots, and refracted ray also has only arrows at the particular angle of incident. That angle of incident is called angle of polarization. Okay student, next I am going to discuss about the derivation. Before that I gave you information, different books have their different letters. So IP is the angle of polarization, theta P also represent the angle of polarization, theta B also represent the polarization angle. So B represent Brewster's angle. Okay, now continuation derivation. Angle of incident is equal to angle of reflection from the law of reflection from the plane surfaces by the light. See student, angle theta p, which is equal to angle R1. R1 is the angle of reflection and R2 is the angle of refraction. Theta p is the angle of polarization. Here reflected ray and refracted ray mutually perpendicular to each other, so that is 90 degrees. Okay, so that I can write R1 plus 90 degrees plus R2, which is equal to 180 degrees. Notice that angle of reflection and angle of refraction and reflected ray and refracted ray mutually perpendicular to each other. That's why R1 plus 90 plus R2, which is equal to 180 degrees. That's why R1 is replacing with theta p. okay, and plus R2 which is equal to 180 minus 90 which is equal to 90, so that I can write R2 which is equal to 90 minus theta p. This is the first equation. In this, angle of refraction which is equal to 90 minus theta p. Theta p is the angle of polarization. Okay, and also I am going to apply the Snell's law when light is traveling from the rarer medium to denser medium. See student, the basic formula is mu1 sin I which is equal to mu2 sin R. Okay, and mu1 is equal to refractive index of air, and sin I angle of incident is angle of polarization theta p, which is equal to mu2 is refractive index of glass mu g, and sin R is replacing with R2 student, angle of refraction. So that R2 value from equation number 1 I wanted to replace, that is sin of R2 which is equal to 90 minus theta p. Since I can write there R2 which is equal to 90 minus theta p, so that mu a refractive index of air is 1 into sin theta p which is equal to mu g into sin 90 minus theta which is equal to cos theta, that is cos theta I wrote here, and rearranging that equation, that is sin theta p divided by cos theta p which is equal to mu g, and sin theta by cos theta which is equal to tan theta p which is equal to mu g. This I can write as equation number 2 students, and then continuation theta p which is equal to tan inverse of mu g. This is I can write as equation number 3. See, this is clear information about the Brewster's law, and related problems are there. First problem is when unpolarized light is incident at an angle theta p which is equal to 60 degrees given on a transparent medium, okay, from air to light is reflected is completely polarized. From air light get reflected, the reflected light is polarized. How we can notice? There is a analyzer arranging, so whenever light is passing through the analyzer, the dots has stopped, arrows only releases, so that the reflected ray has only dots. That's why there is no light will be appear when polarized light with dots traveling through the analyzer, so that there is no output because of dots has stopped by the analyzer. Okay, similarly we can discuss same analyzer is arranged for the refracted ray. See student, refracted ray has only arrows, so all the arrows refracted through the analyzer. Because of analyzer is only stop the dots and it transmit the arrows. See clearly 4 arrows are there, we are getting output is also 4 arrows. Notice the difference. When unpolarized light angle, that is angle of polarization is 60 degrees is given, and next the basic formula, and which is asking in the question, that is R2 is asking, that is angle of refraction is asking. So that here the basic formula already I gave you from equation number 1, that is R2 which is equal to 90 minus theta p. So the value is replacing now R2 which is equal to 90 minus theta p is 60, so that R2 which is equal to 30 degrees is the answer for the given question. Yes, next question. Given below are two statements. Statement 1, if the Brewster angle for light propagating from air to glass is theta b, that is light is traveling from the rarer medium to denser medium, angle of Brewster, that is angle of polarization, is theta b is given. And what is asking, so that when the Brewster angle for the light propagating from the glass to air, that is denser medium to rarer medium, is asking the value also given in that statement 1, that is 90 minus theta b. So we have to do the proof. And then second statement, so second statement, Brewster angle for light propagating from the glass to air is tan inverse mu g given, where mu g is the refractive index of glass. In the light above the statement, choose the correct answer from the options given below. Okay, statement 1 is false and statement 2 is true. Second option, statement 1 is true and statement 2 is false. And third option, both statements 1 and 2 are false. And fourth option is both statement 1 and 2 is true. There is one principle, based on that we have to solve this question. The principle is principle of reversibility. When light is traveling from a rarer medium to denser medium or denser medium to rarer medium, it follow the same path. See student, light is traveling from rarer medium to denser medium and denser medium to rarer medium. Path is same but direction is different. Here first one, light from the rarer medium to denser medium. Second one is light from the denser medium to rarer medium. So that in the question clearly mentioned in the first statement, that is angle of polarization is Brewster angle theta b given, and R2 is the angle of refraction. So that light is traveling from denser medium to rarer medium, also the R2 angle of refraction, which is equal to angle of Brewster, that is theta b dash I am considering, because of light is traveling from the denser medium to rarer medium. So in the question given, rarer medium to denser medium is angle of Brewster is theta b. So that reverse is considering theta b dash, because of we have to find theta b dash, that is equal to R2 basic equation I wrote, R2 is equal to 90 minus theta p, that is from equation number 1. Okay, so principle of reversibility of light is considering, so that now R2 which is equal to theta b dash, which is equal to question, that we have to find out. And next one, 90 degrees, that is equal to pi by 2, and also theta p angle of polarization according to the question theta b student. Okay, and these values are replacing in the above equation, that is theta b dash, which is equal to pi by 2 minus theta b is the answer. This statement is correct. Okay, and next one, statement 2. In the statement 2, light is traveling from the denser medium to rarer medium. Okay, so the condition is asking angle of polarization. Okay, so same considering when light is traveling from denser medium to rarer medium, theta b dash considering, here also theta b dash taken, and R2 is the angle of refraction. The basic formula R2, which is equal to 90 minus theta b dash, that is from the equation number 1 basic equation only. Okay, so that here angle of polarization theta b dash taken, that's why here also I am writing theta b dash according to the concept problem. Okay student, then that is applying this Snell's law, that is mu1 sin I, that is mu g sin theta b dash, which is equal to mu air sin or 2 student according to the question. And then continuation derivation, that is mu g sine theta b dash, which is equal to refractive index of air is 1 into sine R2 value is 90 minus theta b dash. Okay. Yes student, everything is depend on the first equation and next second equation only I am doing. Okay, so first equation using and finding the solution. Okay, and mu g sine theta b dash, which is equal to cos theta b dash, and next one sine theta b dash divided by cos theta b dash, which is equal to 1 by mu g. So from this equation I can write, that is tan theta b dash, which is equal to 1 by mu g. Okay, theta b dash, which is asking, okay, that is equal to tan inverse of 1 divided by mu g. In the statement 2 given, so tan theta b, which is equal tan inverse mu g, but we got tan inverse 1 by mu g. That's why second statement is false. So that B option is correct, student. See, clear information is given. Please do like and subscribe our channel Nature of Physics. Okay student.